Once we determine a situation is binomial, how do we calculate the probability of a given event? All right, so we need to figure out all the different ways we can have those certain successes and failures. So that's going to be a combination. So as far as how many we have, that'll be the total number of trials. And how many do we need? That'll be the number of successes. Okay, so basically when we use that combination, we're taking care of the order, all the different orders that could happen. It's like we don't care, okay? So we need to now multiply that times the probability of success raised to the number of successes. I stuttered. Successes. Times the probability of failure raised to the number of failures. All right. So our probability of success and our probability of failure must always equal 1. And then the other thing that will be helpful is the number of successes plus the number of failures should always equal our total number of trials. Let's do a couple of quick examples. You are a 70% free throw shooter. Find the probability that you make exactly 2 free throw shots out of 6 attempts. And it looks like I got rid of what we're supposed to round to. Probably need to get rid of that there and check your notes. We're going to round all our answers to 3 decimal places. Okay, so how many total trials do we have? We have 6 attempts. And how many successes are we looking at? 2. So it's 6 total number of trials, 2 successes. What's our probability of success? If you're a 70% free throw shooter, that makes your probability 0.7. And how many successes are we looking at? So to the second power. All right, so 1 minus that 0.7, which would mean your probability of failures is 0.3. And our total number of failures, well, 6 minus 2 would be 4. So this plus this is 1, 2 plus 4 is 6, so I think we're in good shape. So when I type this in my calculator, get 0.060. So we have 60 thousandths. Let's look at B. A certain prescription drug causes dizziness in 20% of all the patients who use it. So I know that sounds odd, but this is going to be our number of successes, or our probability of success. Among a random sample of 10 patients, find the probability that exactly 4 of them experience dizziness when taking this drug. So again, the drug will either cause dizziness or it won't. So that sounds like a binomial probability. And it sounds like our probability for success that it will cause dizziness will be the same on each trial. All right, so how many is the total number of trials? We have 10 patients. And I'm finding the probability that exactly 4 of them experience dizziness when taking the drug. So that's actually a success. So if that happens in 20% of the patients, that makes the probability 0.2. Raised to the number of successes, so that's to the 4th power. So the probability of success is 0.2. The probability of failure is 0.8. 1 minus 0.2 is 0.8. And if you had 4 successes, that means you would have to have 6 failures. Okay, typing this into our calculators. we get 88 thousandths.